November 24, 1944. North Field, Tinian and Isley Field, Saipan. The 21st Bomber Command launches 111 Boeing B-29 Superfortresses toward the Japanese mainland. Brigadier General Hayward Hansell commands the American Strategic Bombing Force from his headquarters on Guam, silver bombers carrying 277 tons of bombs against the Nakajima Aircraft Company's Musashino engine plant on Tokyo's outskirts. What Japanese fighter pilots discover this morning will shatter their understanding of aerial warfare and reveal a technological gap that no amount of courage or determination can overcome. Captain Tatsuo Yamada adjusts his oxygen mask in the cockpit of his Kawasaki Ki-61 Hien at Chofu Airfield outside Tokyo. The morning briefing emphasized intercepting enemy bombers with maximum altitude advantage. Intelligence reports indicate large four-engine bombers operating from newly captured Mariana Islands bases, flying at unprecedented heights. Yamada volunteers for the high-altitude interception mission that promises difficult combat against an enemy whose capabilities remain largely unknown. His aircraft carries four 12.7mm machine guns and two 20mm cannons, weapons designed for combat at conventional altitudes where Japanese fighters excelled. The altitude challenge emerged from Japan's limited experience against American heavy bombers in China during early 1944. Those B-24 Liberators and older B-17 Flying Fortresses operated at altitudes Japanese fighters could reach, typically between 20,000 and 25,000 feet. Major Takeshi Maeda had developed specialized climbing tactics based on those encounters, emphasizing gaining altitude before engagement rather than climbing during combat. A pilot already at altitude possessed energy advantages that could overcome defensive armament. But the morning's intelligence reports suggested these new bombers operated far higher than anything previously encountered. The 21st Bomber Command represents America's most powerful Pacific strategic deployment since the Doolittle Raid of 1942. The command would eventually total over 1,000 aircraft operating from 5 major airfields across Saipan, Tinian and Guam, with pressurized cabins designed specifically for extreme high-altitude operations over vast Pacific distances. This construction philosophy differed fundamentally from previous American bombers. The B-17 Flying Fortress and B-24 Liberator used unpressurized crew compartments that required heavy flight suits and oxygen masks, limiting their effective operational ceiling to around 25,000 feet. American designers prioritized altitude capability in the B-29, accepting complexity in exchange for operational sanctuary above enemy interceptor range. The pressurization system allowed crews to work in shirt sleeves at altitudes where unpressurized aircraft crews would struggle with cold and hypoxia. Yamada's formation includes Ki-61 Hyans from the 244th Sentai and Nakajima Ki-44 Shoki interceptors from the 47th Sentai, climbing desperately from multiple airfields around Tokyo at maximum sustainable rate. The Japanese pilots observe contrails forming at extreme altitude where American formations approach from the southeast. Radar operators at the Chiba Detection Station identify the incoming formation at 27,000 to 31,000 feet, varying their altitude as they navigate weather conditions. Ground controllers vector defending fighters toward the threat axis, but the climbing interceptors struggle to reach even 25,000 feet before the bombers arrive over target. The technological disparity becomes immediately apparent as opposing forces attempt engagement for the first time. Yamada flies an aircraft designed in 1941 for medium-altitude combat against Chinese and early Pacific War opposition. His Ki-61 weighs 7,650 pounds, with a 1,175 horsepower Kawasaki Ha-40 liquid-cooled engine, providing 368 miles per hour maximum speed at 16,400 feet. While specifications claim a service ceiling of 36,000 feet, actual combat performance degrades severely above 28,000 feet. The engine loses power dramatically in thin atmosphere, while control surfaces become increasingly sluggish. Self-sealing fuel tanks and pilot armor had been incorporated following combat experience, adding weight that further reduced altitude performance. The Ki-44 interceptors from the 47th Sentai attempt reaching the bomber formation, which varies between 27,000 and 30,000 feet altitude depending on weather conditions. These fighters, specifically designed for high-altitude interception with superior climb rates, struggle desperately in the thin atmosphere. Engines overheat while producing a fraction of their sea-level power, and pilots gasp through inadequate oxygen systems that were designed for shorter engagements at lower altitudes. The interceptors manage to reach 28,000 feet before most begin stalling, still thousands of feet below many of the bombers. Those few fighters that achieve sufficient altitude lack the energy for sustained engagement. Control surfaces barely respond in rarefied air, while engines strain beyond design limits. The B-29s maintain formation integrity at their operational altitude, crews working comfortably in pressurized compartments without the heavy flight suits or cumbersome oxygen masks that handicapped previous bomber operations. Captain Robert Morgan commands the lead Superfortress Dauntless Dottie, as Navigator Captain Theodore Van Kirk identifies the primary target through the Norden bomb site. The bomber's 4 Wright R350 engines generate 2,200 horsepower each, maintaining over 300 miles per hour true airspeed at operational altitude despite the thin air. Turbo-superchargers compress the thin atmosphere, maintaining engine power where naturally aspirated engines fail. The pressurized compartments connect through a tunnel over the bomb bays, allowing crew movement without altitude suits. This design enables sustained operations at altitudes previously impossible for combat aircraft. The central fire control system coordinates defensive armament through analog computers, tracking multiple targets simultaneously, while gunners operate from comfortable positions. Yamada pushes his Ki-61 to absolute ceiling, the airspeed indicator showing barely 180 miles per hour as the fighter wallows in thin atmosphere approaching 30,000 feet. His pre-war training never anticipated combat at such altitudes. The mission briefing emphasized attacking from above using diving passes to maintain energy, but reaching position above the bombers proves impossible. Japanese doctrine developed against unescorted B-17s and B-24s operating at moderate altitudes proves completely inadequate. The Haiyan sustains 30,000 feet for mere seconds before stalling, forcing recovery that costs 3,000 feet of altitude. Multiple attempts achieve similar results as engine temperature gauges exceed red line limits and oil pressure fluctuates dangerously. Yamada observes bomber contrails passing overhead, their defensive guns tracking his fighter, but not firing due to extreme range. The altitude gulf prevents any meaningful engagement, despite desperate Japanese efforts and early warning of the raid. That morning, only 40 Japanese fighters managed to make any attacks on the bomber formation, most achieving just single firing passes before losing energy. Machine gun rounds fired in climbing attacks lose velocity rapidly in thin air, many falling short of targets. The few fighters reaching effective firing position possess insufficient energy for sustained engagement, managing only brief bursts before stalling away. Anti-aircraft shells explode thousands of feet below the bombers, despite maximum elevation settings on the guns. The largest Japanese anti-aircraft weapons can theoretically reach 30,000 feet, but accuracy at such altitudes proves virtually impossible. The November 24th raid marks the first mass B-29 attack on Tokyo since the symbolic Doolittle raid 31 months earlier. The formation maintains course toward the Nakajima Aircraft Company's Musashino engine plant, Japan's most important aircraft engine manufacturing facility. Chief Bombardier Lieutenant Coleman releases his bombs on signal, followed by other aircraft dropping in sequence from their varying altitudes. Due to powerful jet stream winds discovered at altitude, reaching over 200 miles per hour, only 24 aircraft hit the primary target, with others bombing secondary targets or missing entirely. Yet the psychological impact proves profound. The bombs fall from unprecedented altitude, while Japanese fighters circle helplessly below, unable to reach the attackers. Ground observers watch vapor trails crossing Tokyo's sky at previously unimaginable altitude, beyond reach of defending fighters. Lieutenant Kenji Tanaka coordinates fighter operations from sector control, receiving frustrated reports from interceptor squadrons. Pilots report engines failing, controls becoming ineffective, and inability to sustain altitude necessary for interception. The bombers proceed through Japanese airspace, suffering only one loss, to a ramming attack by a damaged fighter in a suicidal gesture of desperation. Defending pilots expend fuel in futile climb attempts, most returning to base without ever reaching firing range. The technological superiority displayed shocks Japanese military leadership and pilots alike. The 21st Bomber Command concludes its first Tokyo mission with minimal damage from defences, though mechanical issues force several B-29s to divert or ditch in the Pacific. Japanese fighters claim only one confirmed victory through ramming, while bomber gunners claim 5 Japanese fighters destroyed. The altitude sanctuary contradicts every Japanese expectation based on intercepting lower-flying bombers from China bases. This operational failure stems from fundamental misunderstanding of American bomber capabilities and the revolutionary nature of the B-29's design. Lieutenant Commander Minoru Genda observes B-29 operations from Naval Headquarters, analysing Army fighter failures with growing concern. His intelligence reports emphasize the unprecedented bomber altitude that exceeds Japanese interceptor capabilities by significant margins. Even the Navy's latest fighters cannot effectively engage at such heights. The strategic implications suggest requirements for completely new aircraft designs or alternative defensive methods, but Japan lacks time and resources for such development. The intelligence failure reflects limited technical information about American pressurization technology and turbo-supercharged engines, innovations that transformed high-altitude operations. Japanese planning had assumed enemy bombers would operate at conventional altitudes below 25,000 feet, based on all previous experience. The B-29's pressurized cabin concept remained poorly understood by imperial military analysts, who failed to grasp its implications for combat operations. Previous American bombers operating from China bases flew at altitudes Japanese fighters could reach, reinforcing these assumptions. December 3, 1944, brings another concentrated B-29 attack against Tokyo, with 86 aircraft targeting the same Musashino plant. The Japanese response evolves based on the November experience. Captain Teruhiko Kobayashi of the elite 244th Sentai implements new tactics, positioning his fighters at maximum altitude before the bombers arrive, hoping to dive on them with energy advantage. But even starting from optimal position, the Ki-61s cannot reach bomber altitude. The formation includes specially modified interceptors with reduced armor, removed radios, and minimal ammunition to save weight. These stripped fighters achieve marginally better altitude, but still fall short of effective engagement height. Lieutenant Saburo Hayashi leads a specialized ramming unit called Hagakure Tai, formed from volunteer pilots willing to sacrifice themselves. The unit's aircraft strip all unnecessary weight, including most armament and armor protection, carrying only enough fuel for one-way missions to achieve maximum altitude. The modified Ki-61 fighters climb toward the approaching formation with emergency boost engaged, accepting certain engine damage. Manifold pressure exceeds manufacturer limits while cylinder head temperatures approach failure point. Pilots pre-breathe pure oxygen for 30 minutes before takeoff, but the inadequate oxygen systems still cause hypoxia symptoms during extreme altitude attempts. Most fighters stall around 30,000 feet, still below effective engagement altitude. Sergeant Masao Itagaki achieves 31,500 feet in his lightened Ki-61 before attempting a ramming attack against a straggling B-29. The bomber's defensive guns fire continuously, as the fighter approaches from below in a zoom climb. Multiple 50 caliber rounds strike the Ki-61, but Itagaki maintains his collision course. At the last moment, his fighter loses energy, stalling 500 feet below target before entering an uncontrollable spin. The pilot recovers at 20,000 feet, his aircraft too damaged and lacking fuel to attempt another climb. The ramming attacks achieve occasional successes when bombers descend due to mechanical problems, but cannot systematically counter the high-altitude threat. Through December 1944, B-29 losses remain minimal while Japanese cities begin suffering strategic damage. The defending pilots experience profound frustration, watching their homeland attacked while remaining powerless to intervene effectively. Traditional samurai warrior spirit proves meaningless against technological barriers preventing combat engagement. Pilots report feelings of helplessness and shame at their inability to protect Japan despite willingness to sacrifice their lives. Major General Curtis LeMay assumes command of the 21st Bomber Command in January 1945, analyzing high-altitude daylight raid effectiveness with his characteristic intensity. Initial missions achieve poor accuracy due to the jet stream winds discovered at bombing altitude, sometimes exceeding 250 miles per hour. These winds, unknown before B-29 operations, push bombers rapidly across targets, making accurate bombing nearly impossible. Navigation proves difficult while bombs drift miles from intended targets regardless of bombardier skill. Cloud cover frequently obscures targets during winter months, forcing radar bombing with minimal precision. The combination of factors means less than 10% of bombs hit intended targets. LeMay faces pressure from Washington to produce better results. After analyzing the tactical situation, he implements a revolutionary change in March 1945, ordering low-altitude night incendiary attacks against urban areas. This decision transforms the air war over Japan. B-29s strip defensive armament except tailguns, carrying maximum incendiary bomb loads. The altitude reduction from 30,000 feet to 5,000 to 9,000 feet eliminates the jet stream problem while bringing bombers within range of Japanese defenses. The tactical shift means Japanese fighters can suddenly achieve effective interception altitude, fundamentally changing combat dynamics. March 9, 1945, witnesses Operation Meeting House, the devastating Tokyo firebombing mission that reshapes strategic bombing doctrine. The attack force of 334 B-29s approaches at 5,000 to 9,000 feet altitude, finally within reach of all Japanese fighter types. Night conditions and the unexpected tactical change initially confuse Japanese defenses. Lieutenant Yoshio Mitsuyoshi scrambles in his Nakajima Ki-44 from Matsudo Airfield, finally able to reach bomber altitude without difficulty. But night combat presents entirely different challenges. Without airborne radar or effective ground control, Japanese fighters struggle to locate targets in darkness. Searchlights illuminate individual bombers, while anti-aircraft guns engage at point-blank range for the first time. Ki-44s and Ki-61s conduct desperate single attacks without radio coordination or formation support. Mitsuyoshi achieves multiple firing passes against B-29s, observing hits on engine nacelles and fuselages. Several bombers stream flames and lose altitude, but most continue to their targets despite damage. The superfortresses demonstrate remarkable durability, absorbing tremendous punishment while proceeding to targets. Remote-controlled turrets engage attacking fighters with radar-directed fire in darkness, proving surprisingly effective. Japanese pilots, trained for daylight combat, struggle with night engagement techniques. The incendiary attack creates a firestorm consuming 16 square miles of Tokyo, killing an estimated 100,000 civilians in the deadliest air raid in history. Japanese fighters claim 14 B-29s destroyed, the highest toll of the war, but cannot prevent catastrophic damage to the capital. Low altitude enables interception, but overwhelming bomber numbers, night conditions, and the surprise tactical shift limit defensive effectiveness. The success of firebombing validates LeMay's gamble, establishing a pattern for subsequent raids. The tactical shift invalidates Japanese high-altitude interceptor development programs that had been desperately pursuing solutions to the altitude problem. Resources devoted to high-altitude engine development and pressurization research become irrelevant overnight. Imperial Navy Lieutenant Sadamu Komachi flies the new Mitsubishi J-2M Raiden interceptor during B-29 raids over Nagoya in early 1945. The Raiden's supercharged Kase engine enables a 36,000-foot ceiling, theoretically sufficient to engage B-29s. But combat at extreme altitude proves nearly impossible even when fighters can reach bomber height. Controls barely respond while the engine produces minimal power despite supercharging. Pilots report inability to maintain pursuit curves or lead targets effectively in the thin air. Even when reaching bomber altitude, fighters lack performance for effective engagement. The Raiden requires perfect positioning before bomber arrival to attempt even a single firing pass. Climbing pursuit from below remains impossible once bombers pass overhead. Many pilots experience oxygen system failures, causing disorientation or unconsciousness at altitude. The few successful interceptions occur against damaged stragglers descending from formation, not healthy bombers at operational altitude. April 1945 brings coordinated kamikaze attacks against B-29 formations, as conventional interception continues proving inadequate. The Japanese military formally organizes special attack units specifically targeting B-29s. Corporal Kiyoshi Ogawa successfully rams B-29 Torchi over Kawasaki on April 12th, both aircraft destroyed in the collision. This same day witnesses one of the most celebrated acts of heroism in B-29 operations. Staff Sergeant Henry Irwin earns the Medal of Honor when a phosphorus flare explodes prematurely in his aircraft. The device burns through Irwin's face and body, destroying his nose and blinding him. Despite horrific injuries, Irwin carries the flaming device through the bomber to the cockpit window, saving 11 crew members. His sacrifice exemplifies the courage shown by both sides despite the technological mismatch. Special attack units form at multiple bases, with pilots volunteering for certain death missions against the Silver Bombers. These ramming attacks achieve limited success, destroying perhaps 10 B-29s throughout the war, a tiny percentage of the bomber force. The psychological impact on American crews exceeds the tactical results, knowing that enemy pilots will deliberately ram their aircraft. Yet even successful ramming attacks cannot significantly impact the bombing campaign's effectiveness. The central fire control system on B-29s proves remarkably effective against Japanese fighters despite reduced gun positions compared to B-17s. Computer-controlled turrets track multiple targets simultaneously, while gunners operate from pressurized compartments rather than exposed positions. Japanese pilots report unprecedented defensive fire accuracy, with the automated system maintaining tracking even during evasive maneuvers. The remote control system allows continued operation despite battle damage to individual gun positions, unlike previous bombers where gunner casualties meant defenseless arcs. This technological advantage compounds the altitude sanctuary when bombers operate at maximum ceiling. The arrival of P-51 Mustang escorts from Iwo Jima in April 1945 further transforms the tactical situation. These long-range fighters establish air superiority over Japan, making daylight B-29 operations even safer. Japanese interceptors must now contend with aggressive escort fighters while attempting bomber engagement. The few fighters that penetrate the escort screen find themselves pursued while trying to position for bomber attacks. Captain Yasuhiko Kuroe commands the 64th Sentai equipped with new Nakajima-Ki 84 Hayate fighters, Japan's most advanced operational fighter. The Ki-84 achieves better altitude performance than earlier types, with a service ceiling of 34,450 feet under ideal conditions. Maximum sustained altitude reaches about 32,000 feet with reduced armament and minimal fuel load. Pilots report adequate performance up to 28,000 feet before dramatic power degradation occurs. The HA-45 engine, though powerful at medium altitudes, lacks effective supercharging for extreme height. Ki-84s attempt intercepting mining missions where B-29s operate at reduced altitude over water, achieving several victories against bombers below 20,000 feet. These successes demonstrate the fighter's capability when altitude disadvantage is removed. But higher altitude daylight missions remain largely immune from interception despite Ki-84 improvements. The performance gap persists throughout remaining combat operations, with most Ki-84 sorties failing to reach engagement altitude. June 1945 introduces the Kawasaki Ki-100, a fighter converted from Ki-61 airframes with radial engines replacing the troublesome liquid-cooled power plants. The modification improves reliability dramatically, but reduces altitude performance compared to inline engine versions. Ki-100s excel against American fighters at medium altitude, proving highly maneuverable and well-liked by pilots. But the radial engine lacks high-altitude capability, limiting ceiling to around 32,000 feet. Pilots report superior handling characteristics, but insufficient altitude performance for B-29 interception. The Ki-100 represents Japan's best operational fighter, but arrives too late and in insufficient numbers. Japanese aircraft industry produces various specialized high-altitude interceptor prototypes throughout 1945. The Mitsubishi Ki-83 twin-engine fighter promises exceptional altitude performance with turbo-supercharged engines. The Kawasaki Ki-102 heavy fighter carries powerful armament specifically for bomber destruction. Development programs suffer from material shortages, particularly high-grade aluminum and special alloys needed for superchargers. Manufacturing difficulties prevent operational deployment before war's end, with most prototypes destroyed in bombing raids. B-29 attacks systematically destroy aircraft factories and engine plants, eliminating production capability. The Akashi engine works, producing the HA-40 engine for Ki-61 fighters, burns in January 1945. The technological gap widens as American improvements outpace Japanese development efforts, with each month bringing enhanced B-29 capabilities while Japanese industry collapses. Lieutenant Colonel Paul Tibbets leads special training for atomic bomb delivery, taking advantage of B-29 altitude capability. The Silverplate B-29s strip all defensive armament except tailguns, achieving even higher operational altitudes. These modifications ensure nuclear delivery aircraft remain completely immune from interception. August 6, 1945, brings the ultimate demonstration of altitude sanctuary when Enola Gay approaches Hiroshima at 31,060 feet. Japanese fighters launch from nearby bases but cannot reach the lone bomber's altitude. Lieutenant Matsuo Yasui climbs desperately in his Ki-61, struggling to reach the enemy. His fighter achieves 29,000 feet before stalling, still 2,000 feet below the bomber. Other interceptors fare no better, with most failing to exceed 27,000 feet despite perfect weather conditions. The atomic explosion occurs while fighters circle helplessly below, unable to intervene or even identify the special nature of the weapon. Similar failure occurs August 9th when Bockscar delivers the second atomic weapon over Nagasaki. Japanese radar tracks the bomber throughout its approach, providing ample warning for interception attempts. Multiple fighter squadrons launch, but cannot reach the B-29's altitude of 28,000 feet. The technological sanctuary enables strategic weapons employment without any possibility of prevention. Post-war analysis reveals the full extent of Japanese technological disadvantage against B-29 operations. Pressurization technology enabled sustained operations above Japanese interceptor capability throughout the campaign. American crews worked efficiently at altitudes where Japanese pilots could barely survive. Engine turbo-supercharging maintained power at altitudes where Japanese engines produced less than half their rated output. The accumulated advantages proved absolutely decisive in strategic bombing effectiveness. Japanese pilots consistently demonstrated remarkable courage and skill within the mechanical limitations of their aircraft. Individual determination could not overcome fundamental technological disparities in equipment capability. High-altitude combat required engineering solutions beyond Japanese industrial capacity during wartime conditions. Material shortages, particularly special steels and aluminum alloys, prevented development of competitive systems. The B-29 campaign validated American investment in advanced bomber technology and industrial capacity. Strategic bombing effectiveness depended on achieving operational sanctuary through altitude advantage that no amount of enemy courage could overcome. Japanese defensive failures demonstrated the importance of matching enemy technological capabilities in modern warfare. The campaign influenced post-war military aviation development priorities worldwide, establishing precedents still relevant today. General Korichika Anami evaluates home defense failures during final military conferences before surrender. B-29 altitude superiority negated Japan's geographic advantages and fighting spirit completely. Technical inferiority proved insurmountable despite tactical innovation and pilot sacrifice. The recognition of technological defeat influenced military acceptance of unconditional surrender terms. Without the ability to defend against B-29s, continuing resistance became meaningless. Former Ki-61 pilot Lieutenant Naoshi Kano recalls desperate interception attempts in post-war memoirs. "We climbed with everything our engines could give, watching the temperature gauges go into the red zone. My flight leader's engine caught fire at 28,000 feet. He bailed out while I continued climbing, reaching perhaps 30,000 feet before my controls became completely ineffective." The B-29s passed overhead like silver ghosts, unreachable despite our most desperate efforts. The frustration and shame of being unable to protect our homeland haunted us more than fear of death. B-29. Crew member Technical Sergeant Robert Johnson describes observing Japanese fighters from his central fire control position. "We could see them, struggling up toward us, tiny specks getting larger slowly. Sometimes they'd get close enough that we could see details, the red circles on their wings, even the pilot's canopy. Then they'd stall and fall away, tumbling like leaves. A few managed to fire at us, but their rounds usually fell short. It was almost sad watching them try so hard and fail. We had every advantage: altitude, speed, firepower, armour. They had nothing but courage, and courage wasn't enough against physics." Strategic Air Command incorporates B-29 operational lessons into Cold War nuclear delivery doctrine. High-altitude penetration becomes fundamental principle for strategic bomber employment against defended targets. Pressurization and supercharging technology advance rapidly based on combat experience over Japan. The tactical advantages demonstrated against Japanese defences influenced decades of bomber development, leading eventually to jet-powered strategic bombers operating at even more extreme altitudes. Japanese aviation industry studies B-29 technology through captured aircraft and documentation after surrender. Engineers recognize multiple technological generations' separate Japanese and American aircraft design philosophy. Pressurization systems incorporate complex sealing mechanisms and structural reinforcement beyond Japanese manufacturing capability. Turbo-supercharging represents precision engineering, requiring special materials and manufacturing tolerances unavailable in wartime Japan. Remote control defensive systems employ analog computers more advanced than any Japanese military equipment, using vacuum tubes and precision components Japan could not produce. The technological examination provides sobering assessment of industrial development requirements for modern aviation competition. Veteran B-29 pilot Colonel Paul Tibbets reflects on altitude advantage during atomic missions. Flying above enemy fighter capability enabled precise navigation to target without defensive concerns. We knew Japanese fighters couldn't reach us, which allowed complete focus on the mission. The technological sanctuary proved absolute. They could see us, track us on radar, but couldn't touch us. It was like being behind bulletproof glass. Their inability to intercept guaranteed atomic mission success regardless of early warning or preparation. Ki-84 pilot. Captain Iwao Hayashi describes attempting B-29 interception during war's final months. Despite flying Japan's most advanced fighter, reaching bomber altitude remained nearly impossible. The engine would cough and sputter above 30,000 feet, barely producing enough power to maintain flight. Controls became mushy like flying through molasses. We'd make one pass if lucky, firing a short burst before stalling. Watching them continue unharmed while our cities burned below created a sense of helplessness I'll never forget. Analysis of crashed B-29s reveals sophisticated construction exceeding Japanese manufacturing capabilities entirely. Pressurized compartment design incorporates complex sealing systems using synthetic rubber compounds Japan could not produce. Structural reinforcement for pressurization requires precision welding techniques and quality control beyond Japanese standards. Remote turret control systems employ analog computers using vacuum tube technology more advanced than any Japanese military equipment. The servo mechanisms for gun control demonstrate precision manufacturing unavailable in Japanese industry. Even basic components like electrical wiring use materials and insulation superior to Japanese equivalents. Major Toshio Sakagawa commands the 244th Sentai during B-29 offensive, recording unit combat experiences. My pilots were among Japan's best, with years of combat experience. Yet we achieved virtually nothing against B-29s at altitude. Our combat reports consistently describe the same failure: climbing desperately, reaching perhaps 28,000 or 29,000 feet, engines failing, controls becoming ineffective, then watching helplessly as bombers passed overhead. The technological defeat was complete and humiliating. B-29 Bombardier Lieutenant Marcus McDilder observes Japanese fighter attempts during missions over Osaka. The Japanese pilots showed incredible determination. We'd watch them climbing toward us for 15 or 20 minutes, struggling higher and higher. Some would try zoom climbs, trading speed for altitude in desperate attempts to reach us. They'd fire a few rounds, usually falling short, then stall and spin away. Our gunners rarely needed to fire. The altitude was better protection than any armor or weapons. It was a completely one-sided fight determined by technology, not courage. Japanese military attaché reports from Germany describe Luftwaffe difficulties intercepting high-altitude Allied bombers, providing context for Japan's struggles. Even with superior engines and technology, German fighters faced challenges engaging bombers above 25,000 feet. Mi-262 jet fighters achieve limited success through speed and altitude performance advantages unavailable to Japan. Japanese industry cannot develop equivalent jet technology before war's end, despite recognizing the requirement. Attempts to copy German designs fail due to lack of special materials and manufacturing expertise. The technological gap proves unbridgeable given resource limitations and strategic bombing damage to industry. Colonel John Montgomery leads the 9th Bombardment Group missions from Tinian, observing Japanese defensive evolution. Initially, they tried mass interceptions, sending up everything that could fly. By spring 1945, they'd largely given up on daylight high-altitude interceptions. They concentrated on night raids when we came in low with incendiaries. Smart adaptation, but too late to matter. The altitude advantage we enjoyed for most of the campaign meant we could destroy their industry almost unopposed. Maintenance Officer Captain Hiroshi Fujiwara documents chronic problems with Japanese high-altitude fighter operations in technical reports. Engine failures increased exponentially during maximum altitude attempts. The Ha-40 engine in Ki-61s would overheat within minutes at full throttle above 25,000 feet. Oil pressure dropped, coolant boiled despite radiator modifications. Oxygen system malfunctions caused numerous pilot casualties, men passing out at altitude, some never recovering consciousness. Frostbite became common as pilots removed gloves to manipulate controls at extreme altitude. The cumulative mechanical failures made sustained high-altitude operations impossible, regardless of pilot determination. B-29, Engineer Staff Sergeant James Pearson, monitors pressurization systems during combat missions. The cabin altitude stayed at a comfortable 8,000 feet, equivalent while we cruised above 30,000. We worked in shirt sleeves, moving freely between stations. Meanwhile, Japanese pilots were struggling with frozen controls, inadequate oxygen, and engines that could barely function. The technological mismatch was absolute. It wasn't a fair fight, it was barely a fight at all. Japanese radar operator Corporal Shigeo Yamamoto tracks B-29 formations approaching at unprecedented altitude. Our equipment could track them from hundreds of miles away, giving our fighters plenty of warning. But warning meant nothing when our planes couldn't reach bombing altitude. I'd vector fighters toward intercept points, knowing they'd fail. Pilots would report maximum altitude achieved, usually 27,000 or 28,000 feet, then watch bombers pass overhead at 31,000. The frustration in their voices was heartbreaking. We had the will, but not the means. Final Japanese military assessments acknowledge complete failure defending against B-29 high-altitude operations. Despite geographic advantages, warrior spirit and early warning capabilities, technological inferiority prevented effective homeland defense. Industrial capacity limitations made matching American bomber technology impossible during wartime. The recognition of technological defeat influenced military support for surrender negotiations, acknowledging that continuing resistance could not prevent Japan's destruction from the air. Lieutenant Kuniyoshi Tanaka flies final interception sortie August 14, 1945, against reconnaissance B-29 conducting damage assessment photography. His Ki-100 fighter achieves 28,000 feet before engine power loss forces descent, typical of hundreds of failed interceptions. The photo reconnaissance aircraft proceeds unmolested at 35,000 feet, documenting atomic bomb damage for American intelligence. The mission symbolizes continuing technological inability to counter American strategic aviation superiority, even in war's final hours. B-29 radio operator Sergeant William Abel monitors Japanese fighter control frequencies during missions, providing insight into enemy frustration. We could hear their ground controllers vectoring fighters toward us, giving altitude and heading information. Then the pilots would report they couldn't climb any higher, engines overheating, losing power. Sometimes you'd hear anger, sometimes resignation. They knew where we were, knew what we were doing, but couldn't stop us. Technology determined everything. The United States Strategic Bombing Survey conducts extensive analysis of Japanese fighter effectiveness against B-29 operations. High-altitude daylight raids suffered minimal losses to fighter interception throughout the campaign. Approximately 50 B-29s lost to fighters from over 30,000 individual sorties, a loss rate of less than 0.2%. Japanese fighters proved effective only when B-29s operated at reduced altitude due to mechanical problems or tactical requirements. The statistics validate altitude sanctuary effectiveness against contemporary interceptor technology. Former Imperial Japanese Navy Commander Masatake Okumiya evaluates strategic bombing defense failures in post-war analysis. The B-29's altitude capability exceeded our intelligence estimates by at least 5,000 feet. We expected maximum operating altitudes around 26,000 feet, based on B-17 and B-24 performance. When they routinely operated above 30,000 feet, our entire defensive strategy collapsed. We lacked time, resources, and technology to develop effective countermeasures. B-29 pilot. Colonel Robert Robbins describes the psychological advantage of altitude sanctuary. Knowing enemy fighters couldn't reach us changed everything. We flew straight and level to targets, no evasive maneuvering needed. Bombardiers had stable platforms for accurate sighting. Crews stayed calm knowing the main threat came from mechanical problems, not enemy action. The confidence boost was enormous. We owned the sky above 30,000 feet, and everyone knew it. Kai 44. Veteran Captain Yoshiro Aoki recalls watching B-29 contrails beyond reach. Each mission brought the same humiliation. We'd climb until our engines failed, achieve maybe one-third the altitude needed, then watch silver contrails drawing lines across our sky. Traditional warrior spirit meant nothing against aluminum and engineering. We were samurai with swords trying to reach the moon. The psychological impact destroyed morale more than combat losses ever could. General Henry Arnold evaluates B-29 program success despite enormous development costs exceeding the Manhattan Project. The strategic bombing campaign validated every dollar invested in advanced technology. The altitude sanctuary enabled precision attacks and atomic weapon delivery without prohibitive losses. We proved that technological superiority could determine victory without massive ground invasions. The investment in pressurization, supercharging, and defensive systems paid dividends that shaped military aviation for decades. Japanese aircraft designer Takeo Doi analyzes key 61 limitations against B-29 operations. Our fighter was optimized for combat between 15,000 and 25,000 feet, where most aerial combat occurred. We never anticipated bombers operating routinely above 30,000 feet. Modifying existing designs proved impossible. The engine, airframe, and systems were fundamentally inadequate for extreme altitude. Starting fresh would require years we didn't have and resources that no longer existed. Squadron leader Major Teruhiko Kobayashi's 244th Sentai achieved over 100 victories against American aircraft, but minimal success against B-29s. My pilots included multiple aces with years of experience. Against fighters and medium bombers, we remained competitive, but B-29s at altitude might as well have been on another planet. Skill became irrelevant when your aircraft cannot physically reach the enemy. We watched our homeland burn while possessing the will, but not the means to defend it. B-29. Navigator Lieutenant Thomas Cartwright describes the navigation advantages of pressurized operations. Working at altitude without oxygen masks or heavy gloves meant precise chart work and calculations. We could use all our instruments effectively, communicate clearly, move between stations as needed. Japanese navigators in unpressurized fighters dealt with fogged goggles, frozen instruments, and hypoxia affecting judgment. Our technological advantages multiplied effectiveness in ways beyond simple altitude. Japanese anti-aircraft artillery commander Colonel Hiroshi Yamamoto documents the futility of ground-based defenses. Our largest guns could theoretically reach 30,000 feet, but accuracy at that altitude was nearly impossible. Shell dispersion patterns meant hitting anything required incredible luck. We fired thousands of rounds per bomber destroyed, depleting ammunition reserves without meaningful effect. The B-29s flew above effective ground defense capability, protected by altitude as effectively as any armor. Maintenance challenges plague Japanese high-altitude operations throughout the campaign. Engines require complete overhaul after just a few maximum altitude attempts due to excessive stress. Supercharger systems fail regularly, with replacement parts increasingly unavailable. Oxygen systems need constant maintenance while suffering from inadequate supplies of oxygen bottles and calcium hydroxide for CO2 absorption. The mechanical attrition reduces available interceptors regardless of combat losses, creating a downward spiral of capability. B-29 Tail Gunner Sergeant Robert Goldsborough observes Japanese fighter attempts from his isolated position. From the tail, I had the best view of Japanese fighters trying to reach us. They'd appear as specks, slowly growing larger as they climbed. Some would fire from extreme range, their tracers arcing up but falling short. Others would try zoom climbs, trading all their speed for altitude. They'd hang motionless for a moment, almost reaching us, then stall and tumble away. I rarely fired. They never got close enough to be a real threat. The technological mismatch extends beyond simple altitude to every aspect of aerial warfare. B-29s carry sophisticated navigation equipment, including radar and radio navigation aids unavailable to Japanese forces. Communication systems allow coordinated operations across hundreds of miles, while Japanese radios frequently fail. Even basic equipment like heated flight suits and optical gun sights demonstrate American industrial superiority. Japanese industrial mobilization cannot match American production capability despite desperate efforts. B-29 manufacturing incorporates precision techniques and quality control beyond Japanese capability. Assembly line production achieves economies of scale impossible with Japanese cottage industry methods. America produces nearly 4,000 B-29s, while Japan struggles to manufacture hundreds of inferior fighters. Attempts to replicate captured equipment fail due to materials science limitations. Japan lacks access to special alloys, synthetic materials, and precision manufacturing tools required for advanced aviation technology. The industrial technology gap proves insurmountable, given wartime constraints and resource availability. Lieutenant Commander Masahiko Kawamoto leads special attack units against B-29 formations over Nagoya. We modified our tactics constantly, trying everything imaginable. Night attacks, dawn interceptions, coordinated ramming attempts. Nothing worked consistently. The B-29s adapted faster than we could, changing altitudes, routes, and tactics. When we finally developed techniques for night interception, they switched back to high-altitude daylight raids we couldn't reach. They held every advantage while we only had determination. Boeing engineers designed the B-29 specifically for Pacific Theater strategic bombing requirements against Japan. Extended range enables operations from distant bases beyond enemy interdiction capability. Pressurization allows routine operations at altitudes exceeding enemy interceptor performance. Defensive systems provide protection without sacrificing performance. The design philosophy prioritizes technological advantage over traditional bomber characteristics, creating a weapon system rather than just an aircraft. Post-war aviation development incorporates lessons from B-29 operations extensively. Pressurization becomes standard for commercial aviation, directly adapted from military technology. Turbo-supercharging enables routine high-altitude flight for all aircraft types. Remote control systems evolve into modern fly-by-wire technology. The technological innovations transform aviation beyond military applications, establishing foundations for modern aerospace industry. Captain Kazuo Tsunoda commands Key 84 Squadron during final homeland defense operations. Japan's most advanced fighter meant nothing against B-29s at altitude. Below 25,000 feet, we could fight effectively. Above that, we were helpless. Pilots would return from missions demoralized, having never fired a shot. The psychological damage exceeded our aircraft losses. We knew we were beaten technologically, which meant we were beaten completely. The B-29 operations vindicate American strategic bombing doctrine through technological superiority demonstration. Altitude sanctuary enables systematic destruction of Japanese military industrial capacity without prohibitive losses. Strategic effects achieve decision without invasion, validating air power theories. Atomic weapon delivery succeeds due to immunity from interception at operational altitude. The campaign proves decisive air power application through technological advantage rather than mass, establishing precedents for Cold War deterrence strategy. Japanese military leadership recognizes technological defeat implications for continuing warfare. The inability to defend against B-29s demonstrates broader technological inferiority across all military capabilities. Industrial capacity cannot match American production while suffering strategic bombing damage continuously. The cumulative recognition influences Emperor Hirohito's decision, accepting unconditional surrender terms. Without means to prevent aerial destruction of Japan, continued resistance becomes pointless sacrifice. Veteran B-29 crew Chief Master Sergeant Frank Morrison maintains aircraft systems throughout Pacific Campaign. The pressurization equipment was complex but reliable when properly maintained. Turbo-superchargers required careful attention but gave us power at altitudes where Japanese engines wheezed. Every system represented years of engineering development and industrial capability Japan simply didn't possess. We won through technology and industrial might, not just courage. Former Ki-61 pilot Lieutenant Jiro Tanaka survives multiple unsuccessful B-29 interception attempts. Each mission demanded maximum physical effort fighting altitude effects. Breathing became difficult even with oxygen. Hands went numb from cold. Eyes watered continuously from dry air and cold. Then watching bombers proceed unopposed while our cities burned created psychological trauma beyond combat stress. We felt we had failed our ancestors, our emperor, our people, not through lack of effort, but through technological inability. American industrial mobilization produces quantities and qualities of equipment beyond Japanese comprehension. The B-29 program alone costs more than Japan's entire military aviation budget for the whole war. Mass production achieves economies of scale impossible for Japanese manufacturing methods. Precision tools and quality control ensure consistent performance unavailable from Japanese industry. The industrial asymmetry compounds technological advantages throughout the strategic bombing campaign. General Curtis LeMay's tactical innovations maximize B-29 advantages against Japanese defenses. Low-altitude night raids negate altitude advantage but exploit other technological superiorities. Radar bombing, incendiary weapons, and mass formations overwhelm Japanese capabilities regardless of altitude. The flexibility to change tactics while maintaining technological superiority proves decisive. Japanese adaptation cannot overcome fundamental disadvantages in equipment and industrial capacity. The B-29 campaign transforms understanding of strategic air power application. Technology enables effects previously requiring massive ground forces. Industrial capacity becomes as important as military strategy in modern warfare. The precedents established influence military planning through the Cold War and beyond. Nuclear deterrence strategies build directly on B-29 operational experience over Japan. This comprehensive examination of Japanese fighter operations against B-29 raids reveals technology's absolutely decisive role in modern warfare. Despite extraordinary courage, tactical innovation, and desperate sacrifice, Japanese pilots could not overcome fundamental technological limitations. The altitude sanctuary provided by pressurization and turbo-supercharging created an insurmountable advantage. When combined with America's industrial capacity for mass production of complex weapons systems, the technological gap proved impossible to bridge. The B-29's operational superiority over Japan vindicated American investment in advanced aviation technology, demonstrating conclusively that in modern warfare, technological advantage can prove more decisive than traditional military virtues of courage, skill, and determination. The campaign's outcome was determined in American factories and engineering offices as much as in the skies over Japan, establishing precedents that would shape military aviation development for generations to come.